Hello everyone, I am Amolika Bansal, a fresher at IIIT Delhi, and for my digital circuits project, I have to design Synchronous Decade Up Counter and realize the inputs of D flip-flops with 4 input multiplexers using Q1, Q0 as the select inputs. I have to realize the data inputs of the multiplexers with NOR gates, and I have to use the hex display for output. So I'll just show you my file. So this is my file where I first written about some important concepts. Then this is my snapshot of the circuit. So this is my circuit diagram. So I first had to pen down the circuit diagram, and then I made the actual circuit on circuit boards. This is my truth table. So basically, the present state is 0000, so next state is 0001. So basically it's just the next digit, and this is 0, so this is 1, this is 1, then this is 2, like, and so on. And we notice that the next state is just equal to the D flip-flop stage. So this is there, and then I have to write the k maps. Now let's go to the circuit boards diagram. So this is the circuit boards platform, and this is my circuit. And as you can see that my circuit works completely fine, because it is showing the up counting basically from 0 to 9, and then after 9 it goes to reset. That is, it goes to 0 and then it starts again. So this is perfect. So for this, I've given inputs as derived for the k maps. These are my multiplexers, my 4 into 1 multiplexers. I've used 4 of them. These are the NOR gates. These are used because in the topic it was mentioned that we have to use NOR gates. These are my D flip-flops, so 4 of the D flip-flops. And this is a splitter, this is a splitter, and this is my hex display, which is displaying the numbers. So basically, so in the D flip-flops, so these inputs are enable, preset, and the asynchronous reset. So enable has to be 1 for the circuit to work. If I enable this, if I figure this 0, so it stops at 1 digit. So enable always has to be 1 here. And this asynchronous reset, if I press this asynchronous reset to 1, the circuit would reset to 0. So I'll show you this. I press this 0 and the circuit also stops. So I have to keep this 0. So I'll keep this 0 and this 1, and my circuit works completely fine. So this output, the output of my multiplexers goes in the input of my D flip-flops. So this, from M3 it goes to D3, from M2 the output goes to D2, and this, the output of the individual D flip-flops goes to the hex display, and thus the number is displayed. So we have here, you can see Q and Q inverse. So we have to do nothing with the Q inverse. So we just leave it hanging, and the outputs are connected to the hex display. So this is the clock. So if this clock always has to be turned on, if I turn off the clock, so if I do not enable this clock, the circuit would not work like this, like I just show you. So the clock is not enabled and the circuit stopped at a digit. So basically the clock has to be enabled always for the up counter. So this is all for my circuit. Thank you all for having the patience to watch this. Hope you all liked it. Thank you so much.